for data cube. And you can see some of the color has come up because I'm actually working in a code cell. So when I press Shift Enter, that's all good. This one on the side here means that that's finished running. And then in order to connect to the data cube, I'm going to call my data cube object DC. And the way that you call it is you write data cube dot data cube. So that's the data cube object from the data cube library. We tend to give it an app name, and that's just to help us understand all the different people that are using the data cube, but really we can call it anything. So I'm going to call it my notebook. And then that's enough to connect it. This deprecation warning is coming up, but it's not something we need to be worried about. So sometimes when things come up in red, they might just be a warning. It's always worth having a read of them. Okay, so I'm now looking at how to load data using DC load. Specifically, it will require at a minimum a product. So this is actually our Sentinel-2 Level 2A product. It requires the area I want to load my sort of X dimension, the area I want to load the Y dimension, and the time span over which I want to load it. And it tells you a little bit about how you need to provide the format there. So what I'm going to do is before I actually construct that load, I'm going to turn the data I collected into something that's a little bit more useful. So something that's great that I can do in Python is I can actually set up variables that mean something to me. So what I'm doing here is I'm typing bottom and left. So these are two variables. And here I'm going to just copy the latitude and longitude values that I collected earlier. So I know that that one is the bottom because it corresponds to degrees north. And I know that this one is the left because it's degrees east. And what that will do is when I evaluate that cell, this will say bottom is equal to 30.2 and left is equal to 30.5, obviously with the extra decimal points. So I can do this again for the top and the right. Equals, and then again, I'm going to use a bracket. This is called a tuple in Python. And I'm going to copy and paste my coordinates straight in there. Perfect. So I'm going to say that my data product is equal to S2 underscore L2A. I'm using quotes here because I need to pass this in as a string, so a word rather than a number. And finally, the thing I hadn't decided is that I need to pick a start and an end date. So I'm going to call a new variable start date is equal to, I'm going to look at 2020 and January 1st. Again, you pass this in as a string and you can see that that information is available in the loading data notebook. I'm just going to load 2 months worth of data just because I don't want us to be here too long. And Sentinel-2 is data every 3 to 5 days. So 2 months should give me a reasonable amount of data to look at. Ooh. So when I press Shift Enter, these variables are all assigned. If I type one of them and hit Shift Enter, you can see that Python will print out for me the value that's actually assigned to that. So that's a good way to check if things are working the way you expect. I'm just going to cut that cell because I don't need it anymore. Fantastic. Now we can start learning how to load data. So this is an example for the GeoMedian Sentinel-2 product. I'm going to use that as a basis, and I'm going to add a couple of other things that have to do with loading Sentinel-2. So I'll need to assign my loaded data to a variable. So I'm going to call that DS. That stands for data set. You could really call this anything. You could say Sentinel-2. You could say, March data set or anything you want to call it is fine. We tend to use the S and DS with underscores to kind of indicate that they're a data set. So here I'm using this DC object that we did earlier. That's my data cube, and I'm asking it to load. So from here, I'm going to start inputting the information I need. So there's an argument called product, and I'm going to say that that's equal to my variable data product, which is the Sentinel level 2A. Then I'm going to say that my X is equal to left, right. And my Y is equal to, it doesn't really matter, I don't think, whether you go top or bottom or top, but I'm going to go top and bottom. And then finally, I'm going to also put in time equals start date and date. You could also copy, these numbers and these strings straight into here, like they are in this example. I like using variables because you could come and edit these later if you wanted to change them. Another thing you'll see here is you need to specify which measurements you want. These are the sort of satellite imagery bands. So measurements equals, and for that we provide Python a list. So that's with the square brackets. So we use blue, green, red. I'm also going to load near infrared, so that's NIR. And finally, there's a little extra bit that's required. If I actually try and run this, it will give me an error. And that's because this product doesn't actually have a default coordinate reference system. So it's telling me I have to specify the output CRS and the resolution as a part of my query. So I'm going to come back up to my query and just add another line. So here's the output CRS. I'm going to use EPSG 6933 for Sentinel-2. That's going to give me something back in meters. And then it also said I needed to specify the resolution. So in this case, what I'm going to write is -10, 10. And what's that saying is that each pixel is 10 meters. And it's just providing the information that the Y pixels go down in space rather than from left to right. And they go top to bottom instead of bottom to top, which is something it needs. So there is some more information about that in this document if you want to look at it. So see how this has a little asterisk? That means it's loading, which is good. It does take a few seconds. Just double checking I didn't accidentally load a huge amount of data, but it's done, which is great. So when I showed you before that you can just type in a variable and see what it looks like, we can do the same thing with our loaded data set. And what we actually get is something called an X-array data set. So what this tells you is that the data I've loaded actually has 3 dimensions. I've got 24 time steps, 656 X pixels and 414 Y pixels. And it tells me that so I could just look at one of those directly if I type ds.red. And again, that's showing me the actual surface reflectance values that are sitting in there. So that's the introduction so far. I would highly recommend that you also have a look at the plotting notebooks and the basic analysis notebooks.
Hello, everyone. My name is Fong Yuan. I'm an Earth observation data scientist working at Geoscience Australia in Canberra. I'm currently co-leading product development activities in the Digital Earth Africa establishment team. As a data scientist, I enjoy working with different types of data. I'm really excited to be presenting here today. Digital Earth Africa is in its 3-year establishment phase. We're about half year through. The establishment team is led by Geoscience Australia, but with members based in Australia, Africa, and in US. And we're finding and training teams in Africa that will be able to take over so that eventually the program will be run in Africa for Africa. Digital Earth Africa is a platform powered by Open Data Cube. We take Earth observation data taken by satellite, make them easily accessible and easily used, and we turn them into information product that can support decision making and also help address challenges faced by the African community. This may be resource management, food security, or sustainable development goals. In the beginning, this little person sitting in front of a computer working with data, maybe me and my teammates in the establishment team, but we're already starting to work with other users. And eventually we want you and more people in the geospatial community, more data scientists and domain experts to be able to work with our data. The first product we released is about water. We use satellite observations to map the occurrence of surface water. And I don't have to remind you how important water is. Water systems are often dynamic and can be related to many different types of challenges. Here's a news story that my colleague in Africa brought up yesterday. It's about 2 expanding lakes in Kenya. There are lots of images showing how the rising water is causing damages to houses nearby. So we went on to our map portal, loaded up water observations from space products, and on the left-hand side, I'm showing the water extents mapped in 1984, while on the right-hand side, it's showing the water extents in 2019. As you can see, the 2 lakes have expanded significantly. And we will have data covering the entire Africa, so we can map all the expanding and shrinking water bodies. And this is going to be a powerful tool to help understand the water systems across Africa. The next theme we're hoping to address is food security. And Sentinel-2 is one of the data set we're hoping to use. In this example, I'm showing Sentinel-2 time series in true color on the left-hand side for an area in South Africa. On the right-hand side, it's the so-called normalized difference vegetation index derived from visible and near infrared observations, highlighting vegetation. So you can tell easily when crops have been planted, how they grow, and when they're harvested. We're hoping to use similar method and more sophisticated models to map the crop area across Africa. The Sentinel-2 data you've just seen come at up to 10-meter resolution, and it covers the entire Africa every 5 days. We already have 1.5 petabytes of Sentinel-2 data in AWS ready for you to play. And the next couple of months, we're getting more data, including land surface temperature data and also synthetic aperture radar that allow us to see through the clouds. And most importantly, they're going to be in cloud optimized GeoTIFF with stack metadata. So I hope you're all as excited as I am, and I encourage you to try out our platform. And I'm really looking forward to working with you all to realize the full potential of this vast amount of data. Thank you, and good luck with the sprint.
Monica, I just sent you the email.
The story of Africa lies in our land, our water, our forests, our cities, and our people. To keep building towards a sustainable future, we must observe patterns, gather insights, find the power in data, and embrace satellite technology.
When we talk about Earth observation, it's not just the power of where that we now talk about, it's the power of what, where, when.
Digital Earth Africa makes continental scale Earth observation data free, open, and ready to use. Equipped with this information, governments, industry leaders, and researchers can work together to address some of Africa's greatest challenges, from food security, water management, and the stewardship of our natural resources to habitat conservation, growing our cities, and reducing the impact of climate change. Together, we will write tomorrow's story, unlocking the promise of tomorrow from patterns of the past.
So welcome everybody, morning, afternoon, or evening, depending on where you're calling from.
Forêt.
L'histoire de l'Afrique réside dans notre terre, notre eau, nos forêts, nos villes et nos populations. Pour continuer à construire un avenir durable, il faut observer les tendances, collecter les connaissances, exploiter le potentiel des données et adopter la technologie satellitaire.
When we talk about Earth observation, it's not just the power of where that we now talk about, it's the power of what, where, when.
Digital Earth Africa produit des données d'observation de la Terre à l'échelle continentale qui sont gratuites, accessibles et prêtes à l'utilisation. Grâce à ces informations, les gouvernements, les chefs d'entreprise et les chercheurs peuvent travailler ensemble pour relever certains des plus grands défis de l'Afrique. De la sécurité alimentaire, la gestion de l'eau et la gestion de nos ressources naturelles, à la préservation de l'habitat, l'évolution de nos villes et la réduction de l'impact du changement climatique. Ensemble, nous écrirons l'histoire de demain. Libérer le potentiel du futur en s'inspirant des tendances du passé.
So one of the easiest ways to do this is the Digital Earth Africa Maps interface. And the reason I really like this is that you get a really clear visual of the whole continent, and you can sort of easily look where data is available and get the information that you're going to need in order to load it in the Open Data Cube. So one of the nice features, I think, is that you can directly search. So this is pulled up Cairo. And I've zoomed in a little bit. At the moment, this is just a sort of background imagery setting. But once that loads in, I'm going to be able to use this as a sort of guide to find something interesting that I want to look at. So here I'm going to look at these irrigated fields. Okay. So the thing I can do now that's really helpful is that by clicking somewhere on the map, I can actually get some latitude and longitude coordinates.
Hello, everyone. My name is Amelia, and I'm a product advocacy lead for ArcGIS.
Hello, I think at this particular point we can just end it because we've stopped. I think our main presenter has just, I think he left the meeting. So with that, I'll just end the session. Thank you.